when we're talking about an atom of any element, the protons and the neutrons of the atom always live in the centermost part of the atom, called the nucleus. And the electrons actually orbit specific areas on the outside of the nucleus. And all of that, the nucleus and each of those orbits, makes up one entire atom. Okay? So if I've got 20 protons, how many electrons am I going to need? I will need 20 electrons. But here's the deal. I can't just make one big ring here and put all my electrons, put 20 of them all over the place around. I cannot do that. Okay? A man by the name of Niels Bohr, and you don't have to remember this, just think boring, okay? Niels Bohr is the one who discovered that electrons actually live in specific places on the periodic table, or in an atom, in the structure of an atom. And those specific places are called electron shells or orbits, okay? If I look at where I'm going to place my 20 electrons, there's a set pattern, okay? My first little orbit, okay, around the actual nucleus is going to have the smallest amount of electrons. Does anybody know how many electrons go on the first orbit?
Is it 8? Is it 2?
2. So in order to fully complete this shell, I need a maximum of 2 electrons. How many electrons do I still have to place here?
18.
I still have to place 18. Okay, they're not all going to fit on this first shell. I then have to add a next shell.
Oh my God.
Now,
It's right there.
Now, what is the maximum number of electrons that can appear in the second shell? 8. Okay? So 1, 2, 3, 4, 5, 6, 7, 8. Am I done?
No.
How many electrons have I placed so far?
10.
I've only placed 10. How many do I need to place?
18.
I need to place 20 total. So what do? Oh, I make another shell. Okay, how many go on the second shell?
On the second?
Third shell?
8.
8. 1, 2, 3, 4, 5, 6, 7, 8. So where am I at now in my big tally?
I think you're good.
No, I'm not. 2 plus 8 is 10 plus 8. How many am I missing?
2.
I must make one more shell. And I will place 1, 2. So here's the deal. Here's where this is going to blow your minds. Okay? What group is calcium in? What group is it in? What column is it in the periodic table? It is in column 2. How many electrons does it have in its outermost shell? 2. What?
Whoa.
Now, what period is calcium in?
4.
How many actual orbits does it have? 4. What? Holy moly, your minds just got blown. I know it. Okay, so what I'm saying here is in the outermost shell of your atom, whatever atom you're doing, the outermost shell of electrons will always equal to the group number that element is in. Okay, that type of atom is in. And I will write this down on the screen in a moment. The number of periods that the atom is found on in the periodic table will always equal the number of electron shells or orbits that that atomic structure has. Okay, calcium is in the fourth period, so it's got 1, 2, 3, 4. Calcium is in the second group, therefore it has 2 actual valence electrons, 2 outer electrons. Okay? So if we look at this, we see that in any atomic structure, the number of electrons on the outermost shell, okay, will always be equal to the number of atoms that belongs, or the number of groups, that atom belongs to. Calcium has 2 electrons in the outermost shell. It belongs to group 2. Okay? This works from 1 through to 18. And this makes sense if we look. Now, here's a few more patterns for you. Let me just go over the second little bullet here. The number of electron shells or orbits, they mean the same thing. It will always be equal to the period or the row where that atom is found on the periodic table. Okay? Now, let's look at an actual periodic table of elements. So if we look at this periodic table of elements, all right, I want you to tell me how many elements are in the first period. What is the total number of elements in the first period? Just look at the table. There are 2 elements in the first period, correct? We've got our hydrogen and our helium. Are we all in agreement? Oh, wait a minute. Let's go back here. How many electrons can go in the first actual orbit? What is the max number? 2. How many elements do I have in the first period? 2. Maximum number of electrons? 2. I know, your mind is getting blown right now. I know it. How many elements are in the second period on the periodic table? 8. And look at this. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So in the second electron orbit, you can have a maximum number of 8 electrons. How many electrons do you think are going to be in the third period? Or exactly, in the third shell, we've got 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. How many in the fourth? 18. How many in the fifth? 18. How many in the sixth? Not 18. Because here's the deal. These guys down here, okay, all fit in right here. It's like taking a ruler. Does anybody have a bendy ruler with them? One of those plastic rulers that you can bend? Does anybody have one of those? Okay, it's like taking this whole row of substance and having it come and fit in this small little bit. Okay, so if you count all of these plus all of these, you will have 32 elements. And the same goes for the last period. Okay, 32. So when we actually talk about how many electrons are available on each shell, if you forget this 2, 8, 8, 18, 18, 32, 32, don't worry about it. Look at your periodic table. Just count how many elements are in each period, and that will tell you what the maximum number of electrons is in that period. Okay, in that shell. Does that make sense? The last thing in this video that I want to talk about is the idea of something known as valence electrons. All right? Valence electrons, for the most part, are the electrons that are in the outermost shell. Okay? And where that actually differs, the only place it becomes a little weird is when we get to these larger shells. Because here's the deal. When I am an atom all on my own, I'm neutral, I'm stable, right? When I am an atom and I'm bonding to another atom or many atoms, what is it that actually holds us together? Okay, if I'm an atom of sodium and Kristen is an atom of chlorine, what makes it so that we actually bond together so solidly to form salt? Okay, there's something that has to happen there so that when we actually break up, okay, when we dissolve and we're not a molecule of sodium chloride anymore, something has to happen to us to allow us to break up. Because there's a reason that we actually bond together so well, whereas if I'm an atom of sodium and Rose is an atom of oxygen, we may not bond together so well. What is it about certain atoms that allows them to bond together and others that stops them from bonding together? And that has everything to do with the actual Roman numerals that are at the top of all of these groups A. We're going to forget about the B's. We don't care about the B's. We care about the A's. 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. When we talk about valence electrons, those are electrons in the outermost shell of an atom that will actually allow and be shared or given to other atoms to form bonds. There's a reason that sodium and chlorine bond together so strongly and stay together. And it has everything to do with their valence shell of electrons. What is the maximum Roman numeral that you see there? What's the biggest Roman numeral number? 8. 8 is a full valence shell. An atom is at its most stable, or a compound or molecule is at its most stable when that outer shell of all the atoms involved is full. That means that atoms like calcium here, how many electrons does calcium have in its outermost shell? It's in group 2, therefore it has 2 electrons, right? And we drew this. We drew this right here. It's got this guy right here and this guy. But if I tell you that a shell of 8 electrons is most stable, how many is it missing? How many? If it's got 2 and it needs 8, it is missing 6. So is it easier to give up its 2 or to keep its 6? Or find 6? Is it easier to find 6 or get rid of 2? It's easier to get rid of 2. If I'm an atom of chlorine, where is chlorine found here? 17, Roman numeral 7. How many is it missing? 1. Is it easier to take 1 or get rid of 7? It's easier to take 1. So, in the next video, we will talk about valence electrons.